Okay, now let's take a look at these two integrals. And as you can see, they look similar. This right here is 2 to the inverse tangent of x as the power. And this right here, the inverse tangent of x is the base, and then the 2 is the power. And then the denominators are the same. In fact, they are really similar, but you also have to know one little thing for that integral. So actually, let's do this one first. This is actually easier. Let's actually do this one first. Why not? Because I said this is easier. So here we go. I will let u equal to inverse tangent x. Why? Because it works. Because when you differentiate this, you get 1 over 1 plus x squared dx. And you do have this right here. If you want to see a cancellation, just go ahead and multiply this on both sides. So you can get dx being 1 plus x squared, right? Times the u. So you can take this to the u world and you get integral. This is the u. So on the top is just u squared and the bottom is 1 plus x squared. But the dx is this, which is 1 plus x squared du. And as I told you, it works. This and that cancel out very nicely. So you're just having the integral of u squared du. And for this situation, let me actually just write it down as 1/3 u to the third power first, because the u is the inverse tangent. I will put that back right here, and we get 1/3 parentheses inverse tangent of x and to the third power like this. And we're done. Put plus c. Right, so this is what I want to tell you guys. First, do not multiply this and that, because this right here represents the inverse tangent. This does not mean 1 over tangent x. So do not write, don't write, please do not write, don't ever write, just don't. Don't ever put down tangent to a negative 3 power like this in x. No, just don't. In this situation, just write it down with the parentheses, inverse tangent of x inside, raised to the third power, and then of course we have the 1/3 in front, and then of course we have the plus c. Alright, now this right here, it's pretty much the same thing. You let u equal to inverse tangent of x again, and then du is of course the same thing as what we have over there. And perhaps let's see the cancellation again. We get 1 plus x squared du. Now take this to the u world. This time though, we end up with the integral. Top is going to be 2, and then the power is the u, and then of course the base is 1 plus x squared, and dx is this, which is 1 plus x squared du. Cancel out. Now here's the deal. We have to integrate. This is not u squared anymore. This is 2 to the u power du. So you have to know how to integrate by using the power rule, and now this is the exponential version, exponential rule. So here is what you have to remember. Perhaps I'll put this down right here in blue for you guys. Remember, yes, e to the u is easy, but 2 to the u, you do the following. And let me remind you guys, if you differentiate b to the x power, where b is a good base, okay? This right here gives you b to the x times natural log of b. And when b is the special number e, then you just get e to the x. Well, if you integrate b to the x dx, instead of multiply by ln b, you divide it by ln b. That's pretty much it. So you put this down, which is b to the x, but you divide it by ln b, and of course put a plus c. So to do this, you actually have 2 to the u repeats, still on the top like this, but you have to divide it by, the base in our case is 2. So you have to divide it by natural log of 2, like that. In the end, you have to look at what u is. U is of course that, so we'll just put this back. So 2 to the inverse tangent of x all over ln 2. And when you just have one thing inside of the natural log, it's okay for you guys to not put down the parentheses. So that's it, but it's not okay for you to not put down the plus c. So anyway, that's it.